In this video, we'll be using the chain rule as the outside-inside rule. We're asked to find the derivative of each of the following, and our first problem is f of x is equal to 5x minus 2x squared, quantity fourth power. Now our outside part is something raised to the fourth power, and our inside function is 5x minus 2x squared. So to find the derivative of this function, we want the derivative of the outside multiplied by the derivative of the inside. So the derivative of the outside will be 4 times that quantity in parentheses and then raised to the third power. So that's the derivative of the outside part. Then we have to multiply that by the derivative of the inside, which is 5 subtract 4x. Now we can put in our quantity in here. Remember that was just this inside part. So 5x minus 2x squared. Our next example, we want to rewrite this function first before we start using our outside-inside rule. We want to write this radical with a fractional exponent. So our rewrite is f of x is equal to x squared minus 1 raised to the 2/3 power. Remember that this exponent on your radicand is the numerator of the fractional exponent, and the index on the radical is the denominator of your fractional exponent. Now our outside is a quantity to the 2/3 power, and our inside is x squared minus 1. So the derivative is the derivative of the outside, so we'll take our exponent times the quantity to the exponent minus 1, so it'll be 2/3 times the quantity, and then 2/3 minus 1 is a negative 1/3. Then that gets multiplied by the derivative of the inside, which will just be 2x. Now we can put our quantity back in here. It was x squared minus 1. So our derivative then is, if we multiply 2/3 times 2x, we have 4/3 x multiplied by x squared minus 1 raised to the negative 1/3. Or if you wish to write this with positive exponents, we could write this as f prime equals 4x is in the numerator, and then 3 times the cube root of x squared minus 1. Our next example, again, let's rewrite this radical with a fractional exponent. So f of x is equal to x squared times 1 minus x squared to the 1/2 power. Now notice this is multiplication, so we have to use the product rule. So our derivative is the first function times the derivative of the second function, and I'll write out the steps here, plus the second function times the derivative of the first one, which is x squared. Now to do this derivative, we need to use our chain rule, the outside-inside rule. So we have x squared multiplied by, the outside is that quantity to the 1/2 power. So if I take the derivative of that outside part, I have 1/2 times the quantity, and then reduce the exponent by 1. So this is my outside part, derivative, and then that gets multiplied by the derivative of the inside, which is negative 2x. Plus, and then this is just a factor, 1 minus x squared to the 1/2, multiplied by the derivative of this expression is just 2x. And now we just need to simplify this a little bit. I see two terms, so this first term right here, I can cancel this 2 and this 2, make it a little nicer, and this is in the denominator. So let's write that as, I have an x here and an x squared, so x cubed, and then a negative, and then this is in the denominator. Let me write it with a radical. So 1 minus x squared is the radicand on that, and that takes care of all those factors. And then plus, and this is all in the numerator, so I have a 2x times this radical, 1 minus x squared. I'll write that over 1. So I need to get a common denominator so I can put these two terms together. I'll multiply top and bottom of this fraction by the radical 1 minus x squared. So now my denominator is square root of 1 minus x squared, and here I have a negative x cubed plus, and then 2x is multiplied by, when you multiply a radical times itself, you just have the radicand. So let's distribute this 2x. Negative x cubed plus 2x minus 2x cubed. Now I can put these terms together, and this will give me 2x minus 3x cubed over the square root of 1 minus x squared.